Now the last type of simulation that we're going to look at today is going to be an overload case. So let's say that we're stowed and we're going to pull our gear out, or we're pulling it up, and for some reason we're jammed at the gear. And I'm looking at this particular link in general, so I really don't need to include much more in the model in this case other than the cylinder and then the rest of the system. So we're fixed and stuck right here, 10,000 pound force and our actuator. How much are we going to permanently bend the model? So I'm calling this the over pull load case. And we've just right-clicked and said exclude the parts that I don't want in this analysis to reduce the size of the model. And when I look at my strut body, if I say apply edit material, we'll see that we're using a plasticity model. This has a full stress strain curve, and it's starting at the yield strength of the material so that we can actually determine how much permanent deformation we're putting into the structure. We're using the same pins and connectors to hold onto our model. We just have a fixed constraint at the end of our strut cylinder, and then I have a force acting on my piston trying to retract the model. So now when I look at my stress results and we can animate, we can see how much permanent deformation are we putting into the model. So we can slow this up and overlay the original model. And see that if we adjust this to our final time step, there we go. The model does have some permanent deformation due to applying and releasing our force. And because we are in a nonlinear study, I can apply and release my force as a function of time. Now, if we want to look at the magnitude of the permanent deflection, I can display my displacement plot and probe my model. And say, show me displacement as a function of time. So we see we start at 0, the load is maximum, and then we begin to release it at 1 second, and then at 1 second when the load is back down to 0, we do have about 3.7 millimeters of permanent deflection. Now, depending on the type of system you're building, a little bit of permanent deflection under a load case that's not going to happen very often might not be an issue. And so we can evaluate our model for that. And we can start with the linear static study, see if our stresses are getting above yield, and then we can use our connections and our fixtures by dragging and dropping, and then run a nonlinear study to get more information about our design.